Okay, so this is the last video for chapter 6. I guess it will be a shorter one. So at the end of the last video, I asked you to try this question. So what is the probability between 32,000 and 37,000? You can follow exactly same steps as I did here. So standardize, but again, remember you have to standardize these two numbers at the same time. So you get minus 0.6 and 0.4. 0.6 and 0.4 are the new interval for standardized normal distribution. And then because this probability is not a cumulative probability form, so you have to split these 2 points like this into cumulative probabilities. Cumulative probability at 0.4 minus cumulative probability at minus 0.6. The difference is probability on that interval. And then on Excel, you calculate that guy, this probability, and this probability. So as a result, you'll get 38.117%. So I showed you how to calculate probability by standardizing the probabilities. Actually, Excel has its own formula to calculate that. For example, let's think about probability up to 40,000 in Excel. Then what you can use is actually norm.dist. Norm.dist, it drops S. Now it does not have S in here. And then this will give you the option to change the mean and the standard deviation. We are looking for cumulative probability at 40,000 with mean 35,000 and standard deviation 5,000. Cumulative is true. Then you can calculate probability without standardization. Excel does the same thing for you. But the reason why I'm showing you this is, this process is common in statistics. In derivation in statistics, a lot of things will be standardized. So this process is behind the Excel formula, and it is also useful to understand how it works. So I showed you, and I have you practice these steps. Okay. To summarize what we have done so far, we can think of 3 different forms of probabilities using inequality: smaller than, greater than, or between two numbers. And it doesn't matter what you have, you can calculate all the probabilities using one of these like rules, right? So basically transform standardization, standardize X and A, and then make some conversion so that the probability about standard normal is cumulative probability form. Okay, that was the idea. Okay, then the next exercise we have to try is percentile thing. As before, we are inverting the conditional cumulative probability, cumulative distribution to obtain percentiles. We are going to do the same thing for non-standard normal distribution. For example, I want to say 90% of tires last longer than certain miles. What is the correct number in here? So you are looking for, so 90% of tires last longer than that. So that means it is bottom 10%. We are calculating bottom 10%, okay? So statistically, we have this condition. You have to find A such that tire life greater than A is 90%. What is A? That is our question. Then we are going to follow these 3 steps. First, as usual, we are going to standardize X into a standard normal distribution. And then, so in this step, we do not use 90%. 90% is not used. 90% is used in the second step to find B, which is bottom 10%, right? Or like 10 percentile. 10 percentile is obtained from the standard normal distribution. Now, in the third step, we match the information from the left side and information from the right hand side, right? So then we match A and B to obtain A. Let me show you this, how to solve this specific question. We are going to standardize the left hand side. Probability X greater than A can be standardized in this form. Here, A is unknown, so we cannot simplify this anymore. This is the simplest possible form we have. Anyhow, in the end, we are going to obtain A using this form. So we have this standardized probability. Okay, this finishes the first step. And the second step, by the way, 90%, we start from the 90%. From the 90%, you have to find this number that satisfies the same form. So the same form, but we are wondering what comes in this place. That is minus 1.28, right? We practiced this before. So this is 10 percentile, right? Because upside is 90%. So from the bottom, it is 10%. So minus 1.28 is 10 percentile of the standard normal distribution. Then, from step 1 and step 2, we have these two probabilities. So we can match these two guys. These two must be the same number. Same numbers. So we set up another equation like this, and like move the denominator onto the other side and add 35,000 on both sides, so that you get A equals 35,000 minus 1.28 times 5,000, which is 28,600 miles. Okay, so the point is these two things. So here there is an intuitive explanation for this. So remember, standardization minus 1.28 means it is 1.28 standard deviation below the mean. Okay? So A is the number 1.28 standard deviation below 35,000. So you have to start from 35,000, which is the mean. Mean is 50 percentile, but from here you have to go below 1.28 standard deviation, which is 5,000. So 5,000 times 1.28 should be deducted from the mean to satisfy 90%, like 10 percentile. That is this number. Okay, so it is a little different, but basic ideas are the same. Standardization using standard normal distribution information and match them. That is basically what we are doing. Okay, now it is your turn. Then find this number. 95% of tires cannot last up to this miles. So think about whether it is top 5% or bottom 5%, and use these numbers. You can use these numbers and find it based on those numbers. Okay, so think about this. 95% of tires are below this number. So this number is 95% from the bottom, or 5% from the top. Only 5% lasts longer than this, right? So we are going to use top 5% value, z.05. So subscript 05, that is 1.64. So this number should be 1.64 standard deviation above the mean. So 35,000 plus 1.64. Let me do this mathematically. So this is the equation, the condition we have to, we are given, right? So probability tires does not last longer than A is 95%, right? So below A is 95%. We standardize it first without looking at the right hand side. Just left hand side is standardized. We get this. And the right hand side, already we know it is 1.64 because it's top 5% or 95% from the bottom. And then you match this standardized term and 1.64. Then in the end, as I explained, the number you get is 1.64 standard deviation above the mean. So if you calculate, multiply 5,000 standard deviation to 1.64, add that to the mean. That is 43,200 miles. So that is top 5% in the tire mileage distribution. Okay. So this is a summary. Basically, standardize and find percentile from the standard normal distribution and match them. That is two basic answers. And the solution can be interpreted as mean, and from the mean you go above or below by a certain amount of certain units of standard deviation. That is how you calculate percentiles for non-standard normal distribution. Okay, this is the end of the video. We learned in this video about normal distribution, we learned how to calculate these probabilities. Probability smaller than, which is cumulative probability, or probability greater than something, or probability in between 2 points. And percentiles. These 4 types of exercises we did for standard normal distribution, and we use that procedures to calculate the same guys for non-standard normal distribution. The only difference is standardization process is added. So you include the first step is always standardization, and then utilize standard normal distribution information to calculate these objects. Okay, thank you for watching. This chapter is more like a preliminary practice chapter for the following chapters. From the next chapter, it'll be quite different. From now, so far, we learned descriptive statistics and statistical models. We did not think about estimation or inference. We assumed the parameters are known, then how to calculate that. What are the properties? That was our approach so far. But from the next chapter, we are going to think about statistical inference. We do not know something. We would like to guess something, and so that is estimation. And then we are going to ask, how can we estimate that? And how can we guarantee the accuracy of our estimator? So to do that, we need some theory that is coming in the next chapter, and then we start inference. Okay, anyhow, normal distribution is important. That's the conclusion. Thank you for watching. See you later. Bye.